This week we are learning about fossils and the fossil record and what this can tell us about what happened in the past. So let's start with the definition of fossil. As we mentioned, a fossil is preserved evidence of living things from the past. And as was mentioned in the Tim and Moby video, it could be a whole thing like a bug trapped in tree sap that turns into rock. It could be trace fossils, such as an imprint of a leaf or a footprint. It can be fossils of a nest of eggs. It can be fossils of any evidence that the living thing was there in the past. And this is straight from the textbook. This tells you, and it does take a tremendously long time. So it forms obviously in sedimentary rock, and an animal dies. Very often they will form in areas like the bottom of a pond or a lake or an ocean because you get that sedimentation. And if you take a look, I saved the stream tables because you can look and see how the sediment has slowly settled down into layers. So the animal dies and sinks into the shallow water, and little by little sediment covers the animal. Generally, the harder parts are going to preserve the best, right? The bones, the teeth are the most common things to find. In some cases, you do get imprints of the skin or the fins or things like that. So sediment covers the animal. Over much time, the sediment becomes rock, preserving parts. And then, as climate changes or there's uplift or the rocks move, the pond dries up or whatever. And so then, hundreds of thousands of years later or millions of years later, that fossil may actually come to the surface. And this is one of those things we see both in Colorado and Utah and places like this. We have evidence of ocean animals, evidence of very different climates that is preserved in the rock record. So fossils can tell us about the climate in the past. They can tell us about animals that lived in the past. And this is all has to do with the types of plants and animals that are preserved. And you remember last week we talked about uniformitarianism, which was a big, long, annoying word, but you need uniformitarianism to actually understand this or to be able to draw conclusions. Let me see if I can spell this. So that means that if ferns and palm trees lived in warm, humid environments in the past and needed lots of water to live there, then when we find those fossils, or excuse me, if they need those things now, then in the past they needed those same things. Because otherwise there'd be no way we could make any types of conclusions about the fossils and about the climate. Things like pollen can also fossilize, which is kind of interesting. Types of clay, coal deposits are made from living things, usually lots of living things in swampy areas. And then again, even just the type of rock. So if you have that really fine clay, it is usually from areas like this where it settled out of the water. And then index fossil is actually further on in the reading, but I'm going to give it to you here, and then we'll come back to that in a minute. An index fossil, what's an index in a book? An index helps you what? You can find what pages things are on. It kind of tells you what order things are in. So an index fossil is a fossil that was very common in a certain time period, and then it's totally absent or extinct. And so with the index fossil, what you find is that if you find that certain fossil, you know what time period you're talking about. And the dinosaur fossils, to some extent, are like that because the huge dinosaur extinction that we believe was caused by an asteroid meteor hitting the Earth and creating huge amounts of dust and cooling the atmosphere, cooling the weather. So there are no dinosaur fossils that are newer than 65 million years ago. So if you find dinosaur fossils, they are only in particular layers of the Earth, and you know it's at least that old. So that is an index fossil of sorts, and we'll talk about some other index fossils as we move on. Everybody got fossils? Now, we have the law of superposition, which I would call obvious but useful. Can somebody tell me what is the law of superposition? Right, pretty obvious. Super means on top of or better than or newer than, and position. Okay, so the law of superposition is in undisturbed sedimentary rock, the older layers are deeper and the shallow layers are newer. Now again, this is absolutely obvious. So what that's saying is that these layers down here are older than these layers up on the top. Young rock layers, old rock layers. But again, much like uniformitarianism, it's very obvious, but the fact that scientists agree on this, not just as a hypothesis or a theory, but as a law, then we can say, oh, well, I found a fossil of some sort of very strange spider here that I know it is newer than the trilobite fossils I found here. And we know that it's newer because it's in a more shallow layer, and we can make those determinations because we all believe in the law of superposition. So obvious but useful, and we will be looking at this as we look at some different diagrams about different layers and how they formed. Okay? Now with superposition, the law of superposition, it says in undisturbed sedimentary rock. So what does it mean, undisturbed? It means that the layers are in the order they formed. So this is, yeah, undisturbed sedimentary rock. But it turns out that things happen. Plate tectonics move things. There are forces that cause things to fold, right? Maybe a little bit of compression causing some folding here. And then you might have erosion. You might have flash flooding. You might have weathering. Many different things might cause that. And then whatever forces were causing that have stopped. And then you have new sediments being laid down. And then you have a case where these are kind of in the order where the oldest ones are at the bottom and the newest ones are at the top. But you might also be missing some layers. And sometimes the folding or the erosion is even more extreme than this. You might have whole layers that are missing in some areas. So it's something you have to look for. And it's something we'll look for in the diagrams we look at. But over millions and billions of years, things happen and the layers are no longer exactly the way they started out. So law of superposition is only for undisturbed sedimentary rock. I think I've got one more example here of something that happens to disturb sedimentary rock. You might have these very nice layers It says sandstone here at the top. And then we've got shale. Shale is usually formed in a more muddy area. Sandstone, could be desert or beach. Telling you about that. Shale is formed more from mud, maybe at the bottom of a river or an ocean. Extrusion, what the heck is that? What's extrusive rock? Who remembers what extrusive rock is? It's a type of? Very good. So this is lava. Well, no, extrusive formed on the surface. So this was some sort of lava flow, and then the other layers formed on top of it. They can tell by what it looks like. It might look like the Pahoehoe. It might have more air bubbles in it. So they know that it formed that way. So that's extrusive rocks. You would normally find it on the surface up here, but more layers formed on top of it. Now, over here we have what's called an intrusive rock, which means it forms inside the surface of the earth. So here we have magma that came up through a weak spot. It says because the intrusion cuts across the shale must be older than the intrusion. So magma cuts into existing rock. Now this is really important because this is the most common mistake, and you will see questions like this on the quiz on Friday and on the unit test. If I showed you this picture right here, which layer is the oldest? The bottom one. Which layer is the newest? The sandstone. And you could order them. This is 1, 2, 3, 4 for newest to oldest. Now, how about in this picture? Which one is the oldest? It's still the one at the bottom, of course. And then which one came next? And then this one. Right, but when did this happen? The sandstone is covering it, so probably this happened and then this. And sometimes you'll even see this will spill out like this a little bit, so you know that the magma and then turned into lava here, and then the sandstone formed on top of it. But a really common mistake that kids make is they look at a picture of this and they go, oh, well, this magma goes down lower than this, so it must be the oldest. But no. Intrusions obviously are newer than what they cut through, right? Because the lava wouldn't just go make a random tower up in the air, right? All right. Okay, so now we put these things together to come up with how old are the rocks. And we have relative dating, not as creepy as it sounds, and absolute dating. I know, see? Relative dating actually means comparing the age of the rock to other rock. So for example, what you just did with those layers of rock and the magma intrusion, that's relative dating. You said in this other picture, you said the magma intrusion is about the same age as the shale, it's newer than the shale. You know that because of when it formed. That's relative dating. So in this, which layer is the newest in this picture? And it's hard to read, but this says A, B, C, D. So which layer is the newest? D. So that's relative dating, is that D is the youngest, and that B is older than C and younger than A. That is relative dating. So layer B is younger than A, older than B. So it's just comparing. And then absolute dating is actually what? So it's giving an actual date, an actual number of how old it is. Right. So this one's easy to do. You just look at the picture and say, oh, it's younger than the dinosaurs. It's older than the dinosaurs. It's about the same time as the dinosaurs. Absolute dating, you have to have something to actually tell you the date. And for that, you read about the radioactive dating. We're not going to go into that in a tremendous amount of detail. But basically, there are radioactive minerals or radioactive rock that the radioactive particles decay at a very steady rate. So it's almost like having a timer. They can look at it and say, oh, this is at least however many thousands of years old. Carbon dating goes in the realm of thousands and I believe tens of thousands. And then you need the uranium dating for much older stuff. And it's not accurate to the year, but it gives you a time frame of how long ago something happened. I'm sorry, I wrote that wrong. Yeah, so B is younger than A, and B is older than C. Sorry about that. Yeah. B is older than C. It formed before C. All right. All right. So next we're going to do an activity to practice this, but that is the main idea that you need from the last. That's the main idea you need